Hey, this is OXDF, and today we're doing the coder box from HackTheBox, and specifically in this video, we're going to look at we have a backup from a time-based 2FA generation, so those little 6-digit codes. There's a Chrome and Firefox plugin that generates those, and we have the backup of one of those, but it's encrypted. And so what we're going to do is we're going to go to the source code for the plugin, and we're going to understand how a user password is taken and used to actually do two sets of AES decryption from this data to recover the seed that is used to make the TOTP value. And once we understand that, we're going to write a JavaScript brute forcing script that we can run to recover that password. Basically try everything in RockU to see if we can get the password off of this encrypted backup, and we will. So let's go ahead and take a look. All right, let's start by taking a look at the backup file that I've managed to pull out of a KeePass database. If you want the full details on how I got to this point in the box, there will be a link to my blog post showing the full solve for Coder on my blog. But this video is going to be focused on recovering the TOTP secret from this blob of data here. So I've got this data. It's got these blobs up here as well as a key thing down here. This is exported from a time-based one-time password generating utility. So it would make sense here that I've got some sort of like key value down here that's being used to encrypt things, as well as some number, one or more of these blobs up here for each site that I have in my Authenticator. Let's jump over real quick. We'll actually see that as we go along in the video. This actually right here is the Authenticator plugin. There's a Firefox and Chrome version. It's a fairly common plugin. There's nothing fancy about it. It just generates codes. And I've got it installed over here. We'll take a look at it in a minute. But first, let's actually go ahead and dive in and take a look at the source code. So we're going to come up here and we'll jump back to the head of the page here. The first thing we can do to find this is look at this webpack config.js file. And this is going to be the thing that sets up how the plugin works. And so you can specifically see here the module exports. And what is it exporting? Well, there's an Argon one, there's a background, there's a content, pop-up, import, etc. Import is what jumps out to me, right? Because what do we have? We have a backup, and I want to see how that thing is decrypted. Well, that's going to happen in the import process. So we're going to go look at source import.ts. We'll come here and come down to the source folder and import.ts. And if I scroll down here a little bit, I will see decrypt backup data right here. And this function is going to take in backup data. In fact, let me put this over to the side. Oops, let's try again. Put it over to the side, and we'll come here, and there we go. So pull that back up. And now we can sort of look at this data as we do it. Might make this a little bit bigger. Perfect. Okay, so decrypt backup data right here. It's going to actually loop over each of the keys in backup data. And so that's actually what these GUIDs right here are going to be. And we can see that because for each one, it's going to make sure that the hash object exists. Now that actually exists in both of these objects. But then it's going to say, okay, does the hash, let's see, if not backup hash secret. So it's going to take that hash and it's going to look at the value here and then secret. So now we got this is secret. It's going to make sure that exists. And otherwise it continues. And then if we have a passphrase, we're going to actually call backup data secret is equal to the crypto library .aes decrypt, and it's going to take in the secret value. So that's this right here. Looks like a base 64 encoded value and a passphrase, and it's going to return the backup data. So we now see that we're going to have some password that gets passed in, and it's going to decrypt this secret, and that's going to be the seed for the TOTP. So we naturally want to know, okay, where is this called? So I'm going to copy this. And one of the reasons I'm doing this in my Firefox outside of my VM is because I need to be logged into GitHub to be able to search like this. And I don't like logging in inside my hacking VM. You can see here, I'm searching within this repo. I want to search for the decrypt backup data function. And you can see right here, so here's where it gets defined. We just looked at that. Here, source components import text import view. View is like a front end JavaScript framework. So that seems like a good place to work. File import also might be a good one to look at. Probably do similar things. We'll take a look at this one. And we can see here on line 25 is where it gets imported. And then lines right here, decrypt backup data right here. And it's going to pass in export data. And it's going to pass in the password, which is going to be the crypto.js AES decrypt function with key.encrypt and the passphrase. And so you can see here, key encrypt is this right here. And so what this tells us is we are going to take this blob right here and a passphrase that comes in from the user. And we're going to use that to decrypt another key that then gets passed to AES again to decrypt this thing. And that is going to give us the TOTP seed. And so once we have that idea in our head, we can start to try to craft a script that's going to generate, that allow us to do that and try passwords over and over again. Now to do that, I'm going to want to get some data of my own. I don't know what the right result looks like, but I want to make sure I know that it works on some data of my own. So I'm going to come here. I've actually already created, if I click the pencil and the plus, I can make my own little TOTP value here. If we come up here to security, we can set a password. So we can set a password, making something very easy to break. Success. So now if we click here, I guess we're still encrypted. That's good. If we go to backup, now we can do backup, download password protected backup, which we will do. And so here we are. Let's see, make a new window in this folder so we can move from downloads. What was it called? Authenticator. I think it was 4. We'll call this auth.json. And if we open that up, hopefully it looks very similar, and it does. That's awesome. You can see all the same kinds of fields here. And so we're going to use this one to try to crack. And then if we prove we can crack this one, because we know the password's password, then we can, we're going to try to use this one because we know the password here. And if we prove we can crack this one, then we can go try to crack the unknown one. So let's go ahead and open up code in this directory. And we'll get a VS Code working. Yes, I trust the authors. And we'll create a brute.js. I'm going to start with my JavaScript is terrible, but we're going to hack something together here. We're going to need the file system. So we'll do require fs, and then we're going to need we're going to use something called readline. So I'll show you how that works. That's just how we're going to read lines out of a file. You need a module to do that in JavaScript versus like in Python. It's much easier, but whatever. And we're going to need the crypto library. So we already saw that. So it's pto js equals require, and I believe it's crypto.js like that. And we can get that. You can get that actually by looking in the source code where it's used in GitHub. I think you don't actually put semicolons here, if I remember correctly. It doesn't matter. Okay, so now over here, let's make this a little bigger, and we're going to want to come here. Okay, this is my test data. Make you a little smaller. We don't need you. Probably get rid of you. So we want we'll say secret is equal to. We'll just grab this, paste it in, and we can say, oh, we need to. Let's see. This will be const. And we'll call const enc is equal to, and we need this blob. Perfect. Okay. Now we've got both of those. Now, what are we gonna do? We're gonna create a read line interface. So we'll say const read line equals, and we're gonna do read line dot create interface, and this interface is going to take input, and that I'm just gonna say fs dot create read stream. And we're just going to pass in process.argv2. And it's 2. Usually when I do this in Python, I'm usually doing argv1 because you have the script and then you have the thing. But in this one, we're going to have to do node, then the script name, then the next thing. So that's going to be 0, 1, 2. Hopefully that makes some sense. And now, oops, we've got this. We'll have our RL interface, which is made for reading lines. So now we can say RL on. And so if we say like line, and we need to do line like this, and we open up a function. So now we have a function that runs on each line. We can say var key is equal to crypto.js.aes.decrypt, and we're going to say enc. So we're going to try to decrypt this thing with line, and the result we need a toString like that. Now we're going to say var, I guess we'll call it like result equals crypto.js.aes.decrypt secret and key. And we'll probably toString that again. And then we can say if, well, let's just do, we'll do console.log. And then we can do, if we put these backticks here, it allows us to put variables inside. So it's like an F string in Python. So we can say line, line, what's our password? New one. And then we can say key, key like that. New line. And then we can say result. And just like we did before, result here. And that looks like we'll print that out. And so we can run this now. Let's see. If I do Control Shift tilde or backtick, I can come here. We can say node. What did I call this? Brute force, and we gotta pass it something. We gotta pass a word list. So let's make a quick word list. Vim test.text, and we can say like we know password is the password. OXDF, please subscribe. Word more. Okay, that seems like a good thing. So now we can say node brute force test and see what happens. And we get an error. Oh, we can't find the module crypto, so we need to do npm install crypto.js. Now we run this, and cool, we got stuff. I'm gonna add an extra new line here so we get some breaks. Cool. So how do we turn out here? So we pass in OXDF, the key doesn't even come back, and we don't get a result. We pass in please, we do get a key back, we don't get a result. Subscribe, same. Password, we actually get something, and this looks useful. Yeah, like it looks like it's in hex, but if you look here, remember we did our seed was AABB, so you can see the AABB. So this is the seed, it's just in hex. So let's go ahead and convert this from hex, and we can do var seed equals, and this is a buffer from result hex to string, that I believe. And so let's actually, we can do seed colon like this, seed. See how we're making progress here. All right, this is looking good. So now you can see actually we got our seed. That's sweet. Okay, we don't want to print this for everything because like when we're going to run rock you through this, and that's going to create a mess. So we'll come down here. We'll say if, and what do we want to call success? I guess seed dot len is greater than 0. Seems like a good start. We will do what? We will grab this console.log. We'll take all that information about the success. I don't know if we need all of it, but why not? And then we can do rl.close just to like close our read liner, because once we get there, we're done, right? So we'll do process.exit, like that. And now we run this again. You can see we just get our password, which is password, and we get back the seed. So that's looking kind of cool. Let's see. What we need to do to actually make this crack the real one is we'll grab this out of here. We could probably, if we wanted to be a little bit more generic about this, we could write it so that you passed it in a one of these config files, but I'm just going to comment it out and write the next one here. So we will do like that, and we'll do const enc equals that, and now we just need to grab here. Got you. Paste. And now, let's see, if we run this with test, we're going to get nothing. That's not surprising because the password is not one of those 5 words I just guessed. But we can do opt seclist passwords leak databases rockyou.txt. We can run this, and we get something that is garbage. Okay, so the seed, we know the seed value is going to be ASCII, right? So let's come here and add that as a criteria. We can say seed length is greater than 0, and we can make a regex here, so we can say begin of line, and we can make a class. So we say OX00 through OX7F, like that. So any character that's in the ASCII range, 0 or more, and then we have a end here, and then we can do close that dot test, I believe it is, test on seed. So now we're only going to get in here if seed is greater than 0 and it's completely ASCII. We could probably look up the seed length also if we need to, and maybe we do, because here we have a seed that is one character. That's not clearly going to be right. Let's make this maybe 10. It seems to be running rather quickly, so maybe if we get more than 10 characters, you can picture a world where a password produces some small amount of stuff that is like decrypts normally, but doesn't give you the full thing. But that looks good, right? Because okay, so here we have a password Skyblade that's giving us this seed right here, and that looks like what we need to keep forward. So that did work for us. This is cool. We will grab this code. This code looks about right. And yeah, cool. I think I'm gonna call it there. I know I've got at least one other video already in this blog post where we do a different kind of brute forcing or cracking something. I haven't done it yet, so but I know there's a place where I said I probably want to make a video for this. So yeah, thanks for hanging out with me, and I will talk to you next time.